Okay, number 2, as soon as you get information about anything that is given in a picture, you have to mark that picture. It says that BE is congruent to BC. So BE, side BE, mark it congruent to side BC. Well, automatically we have a triangle. You see what I'm highlighting? And the sides opposite the congruent, or the angles opposite the congruent sides are congruent. So we automatically mark BCE congruent to BEC. And in this case, you have to use 3 letters because you can't just say angle E because we don't know what angle E you're referring to. Are you referring to AEB, BED, BEA, BEC? You have to use 3 letters. Number 6, the measure of angle BAC, so this angle here. Well, as soon as we see that these 2 sides are congruent, let's go ahead and mark the 2 opposite angles congruent. So if this angle is 60 degrees, then this angle also has to be 60 degrees. And now, if 2 angles in a triangle are 60 degrees, then their sum is 120 degrees, which we can subtract from 180 degrees. So what's left over is 60 degrees. So this actually ends up being an equilateral triangle. So the measure of angle BAC is 60 degrees. Number 12, as soon as you see 2 congruent angles in a triangle, automatically mark the sides opposite those angles congruent. And if those 2 sides are congruent, then we know that the measures of those 2 sides are equal. So 2x plus 4 is going to equal 3x minus 10. So we're just finding the value of the variable, so we're just going to add 10 to both sides. So I get 2x plus 14 equals 3x, and that goes to 0. Subtract 2x from both sides. I get 14 equals x. So x is 14. I'm going to plug that 14 back into my equation. So 2 times 14 is 28, plus 4 is 32. So this side should equal this side. So 3 times 14 is 42, minus 10 is 32. So we have 32 equals 32. We know we did it correctly. Number 14, as soon as you see 2 congruent sides, mark the 2 angles congruent, here and here and here and here. If this angle is 20, then this angle is also 20. Well, in order to get over here, we have to figure out what this angle is, go vertical to that, then subtract all of them from 180 to see what the missing angle is. So I'm going to start with this triangle here. We have 20, 20, and then missing out of 180 degrees possible. So I'm going to subtract 20 more. So that means that this angle is 140 here. That's what's left out of 180 degrees possible. And if that angle is 140 degrees, then vertical to that, this is 140 degrees, then vertical to that, this is also 140 degrees. And if this is 140 degrees and we have 3 angles in a triangle equal to 180, then we know that what's left in this triangle is 40 degrees. But that 40 degrees has to be split evenly amongst the 2 congruent angles, this angle and this angle. So the only way to split 40 degrees evenly amongst 2 is to divide by 2. So this angle is 20 and this angle is 20. So x is 20. Okay, number 18, it says classify each triangle as scalene, equilateral, or isosceles. So if I have triangle ABC on a coordinate plane, A is at 3, 7, B is at 0, 0, C is at -3, -7. Ooh, -3, -7. This is going to be an obtuse triangle for sure. So it's going to look like this. Alright, so now in order to determine what kind of triangle it is, I have to find the length of each side. I can find AB using the distance formula. I can find BC using the distance formula, and I can find AC using the distance formula. So I have x minus x for AB, so 3 minus 0, and I'm going to square it, plus y minus y, so 7 minus 0, and I'm going to square it. 3 minus 0 is 3, and I'm going to square it. 7 minus 0 is 7, and I'm going to square it. So I get 9 plus 7 squared is 49, so I get square root of 58. For BC, distance formula, 0 minus a negative 3. I'm going to square it, plus 0 minus a negative 7. I'm going to square it. 0 minus a negative 3 is like saying 0 plus 3, so it's 3 squared. 0 minus a negative 7 is like saying 0 plus 7, so 7 squared. 3 squared is 9, 7 squared is 49, and that gives me square root of 58. So at this point, I already know I have an isosceles triangle because I have two congruent sides. So now I just need to see if side AC is also congruent, and then it would be an equilateral. So I'm going to do x minus x, so 3 minus x, which is a negative 3, so 3 plus 3 squared, plus y minus y, 7, minus a negative 7, so that's plus 7. I'm going to square it. 3 plus 3 is 6, and I'm going to square it. 7 plus 7 is 14. I'm going to square it. 6 squared is 36, plus 14 squared is 196. Square root of 36 and 196, well, I can already tell that this number is not going to equal any of these numbers. So I already know that the most I can have is an isosceles triangle. In number 20, to find the missing coordinate, well, we already see that r is negative 2a and 0, s is 0 and b, we're looking for t. Well, the easy one is the y value, because we don't go up or down on the y-axis, we go right on 0 on the y-axis. So I know that this 0 is y. Now, we know that this is an isosceles triangle because these two sides are congruent. So if you remember what I said about this x-coordinate is going to be the midpoint of my two sides of this x-coordinate and this x-coordinate. So this is the midpoint, 0. So I'm going to take negative 2a and add whatever my question mark is, divide by 2, and it should equal 0. So whatever this is, my top numerator has to equal 0. Well, how do I get negative 2a and some number to equal 0? Well, the only thing you can add to a negative 2a to get 0 is a positive 2a. So this x value is 2a. So if we check our math here, remember this is our midpoint of our x values. So negative 2a plus 2a divided by 2 should equal 0. So this is 0 divided by 2, which should equal 0, and it does.